This podcast is strictly informational and educational and is not investment advice or a solicitation to buy or sell any tokens or securities or to make any financial decisions. Do not trade or invest in any project, tokens, or securities based upon this podcast episode. The host and members of Delphi Ventures may personally own tokens or art that are mentioned on the podcast.
You're now plugged into the Delphi podcast.
Hello, everybody. Welcome to an episode of the Delphi Digital Podcast. My name is Ceteris. I am coming on the pod now, on Tom's pod. I'm the head of research at Delphi, and I'm bringing on one of our analysts on the infrastructure side. And we're going to talk about this new report that he put out called Solana the Modular. I think this is pretty timely. When we got it out, you've seen a lot of talk recently on Twitter. You've seen people like Austin from Solana had this tweet the other day calling, Solana has these new network extensions, which I guess is kind of a different word than L2 or rollup. You have Kyle Samani talking about how Solana rollups will look a lot different than Ethereum rollups, right? And so instead of getting into kind of like these debates over terminology, which is kind of just like a big waste of time, we just wanted to do this pod, go through some of the stuff on the report, kind of understand why rollups are now coming to Solana, like when did this start happening, what are the implications for like Solana, for Celestia, Ethereum, even Cosmos and like app chains. Is our SVM chains going to be the new app chains, right? So, yeah, brought on Prasad. And Prasad, you joined us how long ago? Like 6 months ago, something like that?
Yeah, around 6 months.
Around 6 months. Okay.
Yeah.
So, yeah, you've definitely been into a lot of these technical pieces. First one with the Bitcoin rollups, right? And this one now. So, just like what made you kind of like want to dive into Solana rollups, and like when did it kind of start getting put on your radar that this was something that had like some real kind of like traction behind it?
So I think generally the separation of SVM from the validator client by ANSA was one of the main developments that I started watching the space. Before that, I was just like taking a look at the banking stage improvements in the scheduler, which were like more focused on making the L1 more improved, right? But this was the first instance in which there was some kind of separation of SVM from the validator. And not just that, the SVM along with the RPC and scheduler are going to be decoupled. So I kind of saw that the validator is getting split apart into a couple of different areas, and this would lead to a lot of rollups, application-specific rollups, app chains, and also off-chain services, which ANSA team kind of highlighted. Along with that, there were a few more developments happening in parallel, similar to what was happening on Bitcoin. So next were a couple of rollups, which looked very interesting to me.
Maybe just to like go back on the SVM thing. So so ANSA kind of splitting that out, this made it now easy for anybody to kind of just go grab that and work with it. I guess in the past, they would have to take like the whole collective Solana code base and kind of like reconstruct it. And I think Solana is like probably one of the most misunderstood code bases out there. It's like my understanding that there's like 20 people in the world that understand SVM. And then, Solana's consensus mechanism isn't formally verified or anything. And so it's very confusing. So yeah, I guess ANSA, by them removing, all the validation and like consensus and just purely having the virtual machine on its own, that was like pretty powerful move to kind of like get the ball rolling here.
Yeah, that's right. Because earlier the code base was like very intertwined with each other. So if anybody wanted to use the SVM by itself, there was nothing like SVM that was separated in the code base. So they just had to use the entire code base and take into consideration, all the dependencies with respect to the consensus and so on. So they couldn't make any kind of customizations as such if they wanted to without being tied down by the consensus. Um, yeah, separation kind of makes it very easy to just work with the SVM, which is one of the most battle tested VMs out there after EVM. So I expected that there's going to be a lot of demand from rollups, app chains, off-chain services, and that's what we are kind of also seeing. So yeah, that was one of the first developments out there. Um, Apart from that, there were a couple of rollups which were very interesting, which is Magic Block and the other one was SpiceNet. So Magic Block, I saw the demo of their on-chain game, which was like at a latency of 10 milliseconds or so, which was very, very interesting. Um, and then there was an announcement by Termina as well about launching an SVM cloud. Um, and yeah, I think they are developing some sort of an SDK, also an extension of SVM, which is called an SVM Plus. So along with that, there was three different syscalls on Solana as well, which went live recently, and these are related to ZK verification. So overall, similar to Bitcoin, I was starting to see a lot of developments that were organic in nature, moving towards that direction. And it wasn't like there are some roll-ups and they are trying to figure out the supporting infrastructure, but a lot of these other pieces of puzzles were kind of coming together at the same time. And there was this community also, which was the SVM community, which also developed at the same time. They started discussing about the interop problems, the designs, and overall it seems like a very organic movement. And that's when I
Yeah,
kind of decided.
that makes sense. I think, um, people talk about how, we're all converging and building the same thing in the long run, which is, definitely truth to it. But the path you take there also matters a lot. Like, if I think about why Cosmos ecosystem has mostly failed, which I think it's fair to say that it's mostly failed at this point. Um, I think that I think like the Cosmos thesis of app chains is actually going to be correct in the long term. I think the challenge is that they never had this like one, central hub that you had general purpose contracts on, that you had all these developers come in and like everyone kind of, grew their app there, right? And I think Solana, some people say this is like a narrative violation or whatever, narrative shift, moving the goalpost. I don't really agree with that because Solana is still laser focused on making the L1 as scalable as they're able to, right? Um, and what you're seeing with, rollups that are launching on Solana is that, if you're an application and you want access to shared state, you can just go launch on Solana L1, right? You're always going to have that. You're always going to have that option. And so for a developer, it's a very easy process to go from, okay, if I want shared state, I'm just going to launch on L1 and my app can live here. And then maybe my app like outgrows the L1. Maybe I want my own custom block space, right? Maybe I'm a perp dex. Like perp dexes don't need to share state with anybody else because you have one collateral asset. So it's easy to like app chains. I mean, if there's one thing that app chains have product market fit for, it's perp dexes, right? There's like a million of them. And so I do think the architecture is a lot different than what you've seen in Ethereum. And even what you've kind of seen in Celestia too, because you're kind of just seeing in those ecosystems general purpose chains, whether it's like EVM, there's SVM with like Eclipse now, but you're kind of just seeing the same thing as Ethereum L1 now on like its new rollup and its new kind of ecosystem, right? And then these L2s, like whether it's Base, Arbitrum, Optimism, whatever, they're now trying to like become this new liquidity hub, right? And you're seeing like Base mints all the USDC on Base now, and they want to get like Base L3s, right? And that's just kind of like moving down the stack one step lower. Whereas if you look at these rollups that are actually looking to use Solana they are all actually kind of unique in their own ways. And I want to get into like how some of these are unique. But I think like what you're not really seeing is you're not seeing people launch these, essentially Solana as a roll up on Solana, right?
Right.
Which is very different from the Ethereum ecosystem because like Base, Optimism, Scroll, ZK Sync, Starknet's kind of the only one that is actually different in a sense because it's like Cairo VM, right? But for the most part, you're just relaunching Ethereum on Ethereum, right?
Yeah.
And so maybe we can start to get into like some of these differences in what we're seeing. I know you mentioned Magic Block at the top there. Magic Block is an interesting one because they have like these ephemeral rollups, right? And then they do use the L1 for some stuff. So maybe kind of like walk us through how Magic Block works.
Mm. And I think you made a great point there that building an SVM on top of SVM doesn't make any sense, especially because I think Anatoly and others have also pointed out that if there is contention for a particular state, having a rollup on top of it doesn't really help scaling it, right? But Magic Block is kind of different, and I think in these cases it might really help. So for start, maybe I'll kind of address how Magic Block architecture works in general. So one thing that is very different for Magic Block is that it's highly composable with Solana main chain. And what that means is these ephemeral rollups don't have their own state on which programmers are going to deploy their own smart contract. So the smart contracts, programs, and liquidity, everything remains on the base chain. And what happens is like these applications, they delegate some of the execution rights to these ephemeral rollups. And Magic Block takes charge of provisioning certain execution environment for them. So what ends up happening is you get certain select applications or programs, and they get this customized execution layer for just a specific account or a specific program. So the application could be made up of a lot of different programs, a lot of different accounts, and the application can actually choose which part of their application logic kind of runs on the rollups, while the other part still keeps on running on Solana itself. And the liquidity also stays on top of Solana, so there is no bridging of assets and so on. And so this on-demand burst capacity, which is available for the applications, is very interesting for use cases like DeFi liquidations, let's say, where there's a very high demand, and there could be like the application might have a lot of contention, and these ephemeral rollups can actually be highly customized in terms of the blocks, timing or the hardware used. So actually, it could have a very different performance compared to the SVM. So what the applications end up having is like a very customized execution for only whatever part of the program they want accelerated to be on. So it's, in a sense, it's like a CPU GPU relationship.
Okay, that's kind of interesting. I kind of thought a Magic Block is like some gaming thing. Can you kind of like, so let's go into that liquidation example. So obviously the state of like the lending protocol would be on Solana, the liquidity would be on Solana. And so what happens on this ephemeral rollup? Is it kind of like the auction process or something? Yeah.
Yeah. Let's say the auction would be actually the most demanding part of the program itself. So that program delegates its rights to the ephemeral rollups, and the ephemeral rollup then gets provisioned, and the developers can choose what kind of customization it has. So it can have different kind of fraud-proof windows. It can have different kinds of securities. It has a committee which can sign on top of it. It can also have different block times and custom hardware. So basically, the auction or particular part of the program only runs on the ephemeral rollup, while the other part keeps running on Solana main chain.
Okay. Yeah, that's cool. That's
Yeah.
cool. And then they are also doing a bunch of like gaming stuff too, right?
Yeah.
Where I guess you want to run like specific game tasks that doesn't make sense to put on like the L1, right? But then you can still have the other parts of the game, kind of like on the L1. Is that how it
Yeah,
works?
exactly. I mean, like if there's certain part of the game which has very high demand that can be provisioned to a ephemeral rollup, it can have its own customized security, because it could be microtransactions which are not that depending on security. So it could have a very short fraud window, and it could have custom logic and so on.
Yeah, that's cool. Okay, so that's Magic Block. That makes
Yeah,
sense. That makes a lot of sense. And you can kind of see how that's different from what we kind of think of as a roll up, right?
absolutely.
It's
Yeah.
not some like, new blockchain kind of that you have the shared state and whatever you're doing all this stuff on. It's something that is ephemeral, serves as a purpose. Um, okay, so I think maybe let's move into some other ones, and then we can get into some more, um, more high level questions. Maybe I think the other main one now is like Spice. What's it
Mhm.
called? There's two, right? It's like
Yeah.
PepperDex and SpiceNet, right?
Yeah.
And they've also, I think they've like constructed the blob stream for
Mhm.
Solana Celestia. Yeah, so maybe we can talk about SpiceNet and what they're doing.
Yeah, so SpiceNet is also, again, very interesting. Um, a couple of weeks back, I saw the presentation by Reth on the Paradigm Founders Day. And they also talked about, some kind of customizations in which you could let go of the VM in case you want some enhanced performance. So PepperDex and SpiceNet basically are application specific, and what they're claiming is like the application specific rollup that they are building doesn't really need that kind of expressive smart contract development. So they're kind of letting go of the VM, and what they're using is just a pure Rust execution environment. So that gives them a lot of handle on the performance, as well as what kind of like features they are controlling on it. Other than that, they're also using something called as namespaced optimized Merkle tree. So usually for the execution part in any blockchain, uh, use of state commitments like Merkle trees is often the most expensive part, and parallelization cannot relieve the pressures introduced by use of the state commitments, because there are so many hashes that you have to do and keep on traversing between these Merkle trees. So this optimized Merkle tree that they are using uses a different hash function, which is much faster. They also use some caching mechanism and some compression of metadata. So I think like for execution that becomes much faster again. So that is another customization that they are using. Um,
And that makes it much like more like validity provable or like fraud
yeah,
provable too, right? That's like,
of
yeah, because
course.
I know that's always been Solana doesn't commit to like a global state root, right? And so that's
Right.
always the hardest part with when people talked about making like SVM rollups. It's like, when you have an EVM rollup, every block you kind of have this state root and everything lies underneath it. And then you just prove that with like validity or fraud proof. And then like you're good, right? And with SVM, it didn't have that. It had this like
Yeah.
continuous block production thing. And so it wasn't so simple to just say, oh yeah, we're going to make SVM rollups like they did EVM rollups, because you don't have that Merkle root, right? So
Mhm.
yeah, that seems like a pretty big development for them. Um,
Mm.
we do care about the tech at the end of the day, and actually having these rollups be like fraud and validity provable. Of
Yeah.
course, you could like launch some multi-sig SVM rollups if you wanted to. I think the industry has probably gone too far in like accepting a lot of these trade-offs in recent times.
Yeah.
Um, so yeah, so that's cool. And then SpiceNet is like, I think it's like what, like a perp, or is it just like a trading chain like in general kind of?
Yeah. It's yeah, they're building a protocol just for trading perps, and developers can essentially build things on top of it in a permissionless way. So it does not have a lot of expressivity because of lack of VM, but it's as far as the application needs, that kind of expressivity is there.
Okay,
Mm.
that makes sense.
Also, they are working with, I think, Risk Zero. So Risk Zero is basically running a Celestia Light client. And so basically they are able to kind of fetch the, the blobs that they are posting on Celestia and
Yeah.
prove it to
So
Solana.
yeah. So maybe like, why are they using Celestia for DA?
Yeah, that's a great question actually. And PepperDex, since beginning, has been very clear that they don't want general purpose expressivity, general purpose, programming on top of it. So that's why they are letting go of VM. And for the DA also, they want something like that. So Celestia doesn't have any, programming or VM on top of it. So they want the high capacity, as far as I see.
Okay. But it doesn't like Solana still have. I mean, so I know that Celestia has. Solana doesn't have like data availability sampling with DA. They don't have light client support yet. Um, so I understand wanting to use Celestia for that reason, right? Like Solana does have more DA, but if you consider that like, well, Solana doesn't have light clients, it doesn't have data availability sampling, then it doesn't really have more DA, kind of, right? Um, so if Solana did, it sounds though like even if Solana did have that, they don't like the fact that there's still all this execution happening on L1 and they still just
Exactly.
want, and because they're afraid that congestion on the L1 is going to cause like the blobs to spike.
Exactly.
Yeah. I mean, that makes sense. I think that is a good feature of a pure DA layer for like another rollup to use. Whether that's good, I still am very skeptical that pure DA layers are kind of like viable long term, just because the amount of activity you need. And I know people will say, well, there's like when you have all these rollups using them, they get this economies of scale because like data availability sampling is like it's more scalable, right? The bridging between all the rollups that share the DA layer, bridging is a lot safer. I get all those points. I'm still kind of skeptical that that is still going to be enough to kind of make it sustainable, but I guess we'll see. And so that is I think SpiceNet is a pretty interesting one because it's kind of, proving out two things. It's one, it's proving out like a Solana rollup, and then two, it's proving why you would want to use a Celestia type DA layer, right?
Yeah.
And so both of those are pretty interesting to me. Both of those reasons. But like SpiceNet it's going to have like its own sequencers and everything, right? It's not going to use Solana for anything.
Yeah,
Just
that's
the
right.
bridging, basically. So this is not going to feel like Magic Block, right? Like
Yeah.
Magic Block for a user or whatever. It sounds like Magic Block is mostly going to be used by, well, I guess in DeFi, it's mostly going to be used by like liquidators and like traders and like, so like the average retail user is never going to really use Magic Block for that. It'll kind of happen without them knowing. And then I guess for gaming, they'll maybe be using it, but still the user won't really know that they're using separate chain. Whereas with SpiceNet, obviously this is like a fully separate chain. You got a bridge, all this stuff. So, okay, that makes sense. And then I know like Zeta's doing one that's pretty self-explanatory. Zeta's like perp dex, making I don't know if there's anything unique with Zeta versus like other perp dex rollups, or is it basically just like perp dex rollup on Solana?
Yeah, it's just like the regular PubDex rollup on Solana.
Okay, so yeah, we don't need to go like too far into that. I guess this other one, I know Grass is
Yeah.
one, right? They're doing. Can you explain Grass actually a bit? I know Delphi Ventures is invested in Grass as a disclosure, but can you maybe explain like how this, kind of works?
I think what Grass is trying to do is trying to make some verifiable database available, and for that, basically normal users basically whenever they visit in websites or they can provide their own data. So what they can do is like they can ask the Grass nodes for scraping of this data. And so basically these are the Grass nodes that have extra bandwidth capacity who can do the scraping of data for the clients. What Grass wants to actually do is prove that the data was actually scraped in a it's not a fake data or it's not synthetically generated data. It has to be real data, right? And for that specific purpose, Grass is actually using like an L2 only for generation of ZK proofs. So all the other parts of the execution are not necessarily using the L2, but the L2 only does the proof generation part. I think it's similar to what ZK like TLS is trying to do.
Yeah, this kind of sounds like, I mean, is like coprocessor the right term? Or,
I think yeah, like a ZK TLS coprocessor maybe, like proofs of correct just scraping of data.
yeah.
It's not necessarily creating proofs of state transition.
Okay. Okay. I guess it's a network extension, right? All right, that was a bad joke. Okay, so I guess now let's move on. I think
But I think
yeah.
I broadly do agree that there is so much diversity of these L2s on Solana. For example, like Magic Block is more or less like a coprocessor. SpiceNet is definitely an L2. Grass is somewhere between. Again, there's GetCode, which is again just using a sequencer for increasing the reliability. Again, it yeah.
Yeah, how does GetCode work again? I know like Rinko was talking about that a while ago. He kind of explained it. They use so Code is this payments app, right? But they use their own token, right? And so they have this sequencer. Do you understand how it works like at a high level?
Yeah, I think at a very high level, not very deeply, but as far as I understand, they are trying to, since like payments are very, um, you know, like the consumers for payments really need high reliability. Right? The payments cannot, fail in terms of the transactions. Also, there needs to be some kind of privacy for payments. So there has been a problem of reliability of transactions, like landing them and getting them confirmed on Solana. So this sequencer kind of holds these transactions and ensures that they are reliably posted on Solana, and these get actually executed later on. And it has some sort of like privacy encryption. So it's only for these two purposes that they are using the sequencer.
So I guess like let's say people like to talk about Solana's outages. I think that's fair. I think it's fair to assume Solana goes down once a year, maybe more, maybe less, depending on how much it improves. But let's say you're using code, Solana goes down. Their sequencer is still going to be like processing all your stuff. Now, though, you're just like kind of waiting. You're fully reliant on this
Yeah.
you're fully trusting, I guess, code sequencer until
Yeah.
Solana comes back up. Right. So that's kind of like,
Yeah.
yeah, which I think is an okay, like, I think what we've seen in the last year or two is that liveness issues kind of affect everybody except for Ethereum L1, but there's obviously trade-offs with their design, right? And so I think you're going to see L2s have liveness issues like we've seen a bunch, right? Like every L2's kind of had a liveness issue with their sequencer. Solana's had issues, and so I do think this is kind of like a bit off topic tangent. I do think there's like some sort of market or something that can be designed to like kind of allow state to maybe like still progress while there is a liveness issue. With obviously you're going to have more trust assumptions. It's going to be a bit more centralized, but I feel like there's some sort of trade-off. There's some sort of design there that probably makes sense as like a fallback type mechanism, but I guess we'll see.
Yeah, I do agree.
Yeah.
I do agree. Reliability is one particular area where I think even the Solana people have agreed that L2s for that make sense to improve reliability, and to also reduce latency, and to add privacy, and for the compliance purposes. I think like these four things are actually kind of adding to the Solana main layer. And I don't want to call them extensions, but yeah, definitely these are things that L1 is currently not providing, and L2s might want to build something to address that.
Yeah, that makes a lot of sense. So maybe I think one more kind of want to talk about here was Sonic, and then maybe we can maybe move on to some other things like there's like Tiny Dancer, there's Roam, the shared sequencer. But yeah, maybe we can talk about Sonic. I've seen this a decent amount on Twitter. Um, Maybe you want to explain kind of like this is like a gaming focused thing too, right?
Yeah, yeah. Sonic is completely focused on gaming, and basically Sonic is like a horizontally scalable, like a like an ecosystem more than an L2. So it has something called as grids, and grid is essentially an execution environment similar to what SVM is. But what the games can do is basically they can either choose to deploy on top of Sonic, or they can just spin out their own grid. And also these grids are basically if you run out of the capacity on a single grid, you can get another instance spun out of it. And also these are kind of fault tolerant in nature. So let's say a program on a single grid kind of dies off, they're cloned and they run on the other grid. And Sonic also has an interesting customization again on the state commitment side. So instead of Merkle tree, again they're using something called as concurrent Merkle tree. So that's very interesting because on a regular Merkle tree, it's like similar to a sequential execution. So you can just update one thing at a time. Concurrent Merkle tree again can update multiple things on the Merkle tree at a time. And so, yeah, it kind of extends that parallelization to the state commitment side as well. Also, Sonic has a sequencer, and the sequencer kind of acts like a bridge for all these different grids. And that also creates like a ZK proof for settling. And Sonic is also using ZK compression. So ZK compression is not an L2, and it just like reduces the cost for state on Solana. So basically what it does is like it offloads a lot of state on the ledger, and instead just like posts commitments on the main chain, right? Basically transactions on Sonic are also again 10 to 100x more cheaper because of the use of ZK compression. So all these microtransactions for games benefit a lot from it. So
Okay, yeah.
yeah.
So just so I understand the architecture, Sonic is like it's kind of like general purpose, the Sonic main chain, and then they have these hypergrids. So it's kind of like this L2 L3 thing, is it not?
Yeah, kind of.
Okay, and then they have their own sequencer um, that sequences all like the hypergrid transactions, all the Sonic VM transactions, and then it'll post that all on Solana L1.
Yeah. Only the difference is like it's going to use ZK compression, so the costs are going to be much lower.
It'll use ZK compression on Solana or on Sonic?
I mean, the accounts can stay on Solana, but they will be in the form of a Merkle tree.
Okay. Okay.
Yeah.
For like a user using something on Sonic, are they gonna have to deal with like bridging and everything? Or will they just live on
Yeah,
Solana? Yeah, okay.
yeah. There's bridging involved, and currently it's an MPC.
Okay. All right, cool. Well, yeah, I think those were like the main kind of roll-ups we wanted to talk about. I guess I would say like a question that, well, I guess first of all, I think you were making this point in your report how like even if Fire Dancer, Fire Dancer is this new client that's coming out for Solana. Everybody's really, bullish on it. We'll see. We haven't like seen it go live yet. But let's say it hits some theoretical, 1 million TPS, okay? Some crazy high number that I wouldn't really bet on right now. But let's just say for the sake of this, it hits it. You were kind of making the point that even in that world, you're still going to need rollups because of the amount of like, if you're comparing it to maybe if you're just thinking about finance and people are just trading, you don't need rollups, right? But if you're talking about if people are actually going to start using like blockchains and all this for just everyday transactions like they use the web, that even like 1 mil TPS is still way too low, right? To kind of like serve all these use cases.
Yeah. Yeah, I think for the argument, there could be a lot of arguments that can be made, for having not rollups, but essentially, 1 million transactions per second not being able to service the actual demand that blockchains are trying to address. So one of the arguments is like taking a look at the daily interactions that a normal user does on our internet, and that comes out to be around 3,000 transactions or interactions a day. And if we do some basic math using 1 million transactions per second as the capacity, it's only able to service like 30 million people. And that is excluding all the surge that could kind of reduce that even low. Um, the other argument could be, so I was just checking out this thing called UTI SIP that's used in NASDAQ. And what it does is like it aggregates a lot of quotes and prices from different venues and brings a singular price to NASDAQ. Um, and this also operates at around 1 million TPS. But what's different is like its latency is 15 microseconds. And even with yeah, 15 microseconds is like around 10,000x far away.
Yeah.
So yeah, it's pretty far away. And the third part of the argument could be looking at the catalysts in the future. So all these AI agents and IoT devices that are going to be the new entities on internet, which are going to do a lot of transactions, interactions, and at a much higher latency. This demand will be also at least like a order of magnitude higher than what human consumption is. So I think like that demand also, especially like AI would need blockchain because yeah, we can't really trust OpenAI or any other AI company to make the decisions for us.
Yeah.
So considering all these arguments, I think 1 million TPS is not really sufficient at all. And yeah, it makes sense to use L2s, which are not really bounded by any hardware requirements. So the settlement, consensus, all of that can be taken care of by a very fast L1. But the execution part can be taken care of by an L2, which can just push the performance to completely next level.
Yeah. No, that all makes a lot of sense. My theory on all of this, and has been for the last few years, is that I believe that like 80% of the finance will take place on like 3 to 5 shared state machines. Okay.
Mm-hmm.
But then there's like thousands of other like things that you've kind of talked about here, right? There's thousands of different things that can use rollups. And so when people talk about this world of like a million rollups, I actually do mostly agree with that, because I think you're going to need rollups, or like maybe coprocessors or network extensions or whatever you want to design. I think you will need that for a lot. But I still think that like 80% or so of the actual financial value moving will happen on L1s, essentially, right? And only a select few of them. And this is why I think Solana is still moving in kind of like an optimal architecture. From my standpoint, and like they continue to make the L1 scalable, they're continuing to have like this FireDancer, right? Anza's trying to make their client as good as FireDancer too, right? Like I don't think we should kind of discount the Anza team and the engineers there as well, right? They have some pretty crack devs that are insanely smart. And so, having FireDancer also as competition kind of lights a fire, no pun intended, like under the other client teams as well, right? And so I just really like this architecture of having the L1 where all the finance lives, for outside, perp dexes and like other stuff like that. But for the most part, you need this shared state. This is where a lot of the finance happens. This is where a lot of the activity happens. And now you can kind of like add these rollups on top when you need these specific use cases, right? Mm-hmm. And this, when I go back to the Cosmos thing, like this is why I think Solana might back into like winning app chains too, in a kind of ironic way, is that they didn't go to the end game right away, right? Like Cosmos might have been right in seeing the end game was app chains, but they started with app chains. And the path to getting there matters a lot. And so like the more liquidity that Solana L1 continues to amass, like I know PayPal, they're putting a lot of like stable coins on there now, more assets getting launched on Solana, RWAs, all this stuff, all the DePIN stuff. Like the more liquidity you start getting on the L1, that just makes it, again, as you're a developer, it's like a very easy thought process. Like I want to go shared state with Solana. I want to be an SVM, like I want to be SVM dev. I want shared state. I'm going on L1. Okay, maybe I've outgrown the L1. Maybe I need an L2 for something else, right? And you kind of make that decision. I just think that's really clean from like both a development perspective, like a social consensus kind of perspective. And so that's why, yeah, like people will say Solana moving modular is like a pivot. It's not really a pivot if you listen to like leadership. They're still laser focused on making the L1 as scalable as possible, right?
Yeah.
And so it's a super important distinction to me.
Yeah.
But yeah, let's touch on a few other things here. I think I want to talk about maybe quickly. I think there's like a couple banks or something that are going to be using the SVM for something. So like we don't have to talk about this too much because nobody likes permission chains, but maybe like what are they doing there?
One of the projects there is kind of building a core for banking operations. So core is essentially just similar to a settlement layer in which a lot of different banks essentially transact between each other, and they just settle between each other, and the core kind of coordinates between them. So there's this team that is building a core which is using the SVM, and it's a separate network. And what I've observed is like the main reason for these financial applications to kind of separate out completely, apart from the main chain, is the control of validator set, because for the compliance purposes of these applications, they can't really trust on validator which they don't know anything about. So the validator set really needs to be controlled, and that's the reason these financial applications are using this. And there's another team which is also kind of building a banking kind of an application. It includes like a suite of services, but what's different is like they want some sort of privacy on top of it. So they are adding FHE on top, which would be very difficult to do on the main chain because I think it would definitely kind of interrupt the progress that they are making on the FireDance side, because introducing FHE would require a lot more hardware, and for those purposes they are having their own separate chain, adding FHE on top of it, also using token extensions. So that's for just the privacy part.
Yeah, that makes sense. There's, when you're building, I know the one thing the FireDancer team has had to deal with is like Solana keeps adding these new things to the code, and then it kind of just keeps delaying FireDancer because now they need to kind of incorporate this. And yeah, FHE is like very computationally intensive, right? And so it makes sense to kind of have this. You want to be, I think the privacy angle is also really important too, because when we think about privacy, most people will think about Tornado Cash, which is, I think it's sad that that's the thing that comes to people's mind when we talk about privacy, because in reality, no bank, no institution, not a lot of high net worth people are going to use these rails if they don't have privacy, right? Like you can't be a business. You can't have all your like accounts payable, receivable, just like on chain who you're paying with like everybody to see this, right? And so, doing this permission environment, which is obviously they're going to have a backdoor, whatever, KYC'd, right? I still think those kind of things make sense. Okay, so I think the last thing I want to touch on here is, and then we'll end it, is Rome protocol. And the reason I want to kind of talk about Rome protocol is because we talk about rollups, and in Ethereum, you're kind of seeing this now. ETH price has been really bad, underperforming, and so now everyone starts doubting the roadmap and doubting all these different things, right? And I think a clear takeaway is that rollups do accrue most of the value to their own sequencers, right? Or like in the future, maybe their own tokens, and not necessarily Ethereum, right? If you look at, Base, it's like they make millions of dollars on sequencing fees, and they pay the L1 like 10K over an entire month or something, right? And so you've seen this push to like based rollups, right? Which uses kind of like Ethereum L1 for sequencing. And I think based rollups make a lot of sense in the sense that they're, yes, I think based rollups, if got adoption, would be very good for, the value accrual of ETH. It'd be like definitely a net positive. I think the challenging thing with based rollups is just getting people to invest in based rollups. If what you're investing in is only going to benefit like the ETH token, right? It's kind of like, so you're investing in a public good almost, and like so maybe the ETH Foundation needs to invest in based rollups. But Rome is using Solana as a shared sequencer, right? And so this is interesting to me because I think Solana actually has a lot of nice properties. If you think about based rollups and all this pre-confirmation stuff, there's a lot of talk about like making the L1 faster and like single slot finality to kind of support based rollups. And this is what Solana kind of already is, right? And so Solana actually makes a lot of sense as like a sequencer for base rollups. So maybe we want to talk through like some of Rome protocol and kind of what their like philosophy is, like what they're building towards. Because I think they're definitely an interesting one.
Yeah, for sure. I think what Rome's main philosophy is to kind of bring out the modular components from Solana and make them usable for different entities. So sequencer is one of the parts, but they're also building a lot of different things like ZK. I think they're also building something like ZK compression. They're also building their own DA and an EVM overlay like Neon, and I think a fast finality layer. But yeah, obviously the shared sequencer is very, very interesting. So how that works is essentially any rollup that wants to use Solana as a sequencer, they have programs on top of Solana as like their rollup programs. And these programs have their own state, and which is like identical to the actual rollup state. And what happens is like, let's say there are 2 or 3 different rollups. They are sending all these transactions. These transactions basically get converted into Solana transactions and into bundles. So there are entities like similar to Ethereum has the searchers who create these bundles from different rollups, and they just bundle a lot of different transactions from different rollups, and they get executed on top of Solana. And what ends up happening is you get guarantees of atomic execution because essentially the rollup state is the same on Rome as well. So if it gets executed exactly, it means that the state is actually valid because it's tracking the same state, right? And there's another entity which ends up processing that on the main rollup. So I think the main benefit is having the atomic execution, which I think has been one of the most difficult things that everyone keeps talking about when there is a sequencer involved, because I think atomic composability is achievable, but execution is not guaranteed, right? There are a couple of other proposals, but I think using Rome makes a lot of sense. The other thing that they do is like they are not interested in exactly capturing the MEV, so they allow the rollups to kind of define how the transactions are going to be sequenced, and those also get encrypted. So what Rome is trying to do is like providing a suite of services along with the sequencer, and allow the sequencing to be done by the rollup itself. So I think it's really interesting in that sense.
That's cool. Are these only like EVM rollups that it supports?
Yeah. So it's very interesting. It's the SVM rollups, EVM rollups, as well as Solana. So all of them get composability because they all of them can be essentially composed into a single transaction and processed on top of Solana.
Okay. Yeah, that's pretty cool. I think we've seen we've been talking about shared sequencers for a long time, and we still don't have them anywhere, right? We don't even have like leader rotation, just like
Yeah.
set schedule. Let's just rotate it every, So, yeah, I think this is definitely an interesting design. I like how they're using Solana validators. I think that's good for Solana. Like
Mm-hmm.
I just believe that sequencing is really where a lot of the value lies. And so I think if Solana validators actually start sequencing all these rollups, I think that's pretty bullish for Solana long term.
Yeah.
Yeah. Okay, well that was good. And yeah, as you said, is doing a lot of other stuff too. I guess we're running up on time here. I just want to ask you one question to kind of end on. This is from Rinko from the research team. He says, is there any reason to, and I think you've kind of answered this throughout the podcast, but is there any reason to believe Solana L2s won't lead to the same issues Ethereum is currently facing?
Yeah, so one of the problems is the composability with the base layer. And I think things like magic block and ZK compression kind of address that because these things are more composable. And I think like if what magic block is actually using the program delegation part can be extended to other rollups, that would be great because they all would be composable with the base layer then. Um, and the other thing is the sequencing part where the alignment between the L1 and L2 is not there because the sequencing it does is by the own sequencer, right? So on that front, actually, Solana being a very fast L1 actually ends up being very good to forge kind of an alignment between the L2s and the L1. And I think yeah, base sequencing would definitely work better than what Ethereum would have currently. Other than that, I hope that Solana kind of takes notes from the chain abstraction stuff on Ethereum to kind of address any kind of fragmentation there would be by the other L2s because I think since it's permissionless, there would inevitably be other L2s which are general purpose on Solana as well. So I think at least they could learn from the approaches used.
Yeah, and I mean, even if Solana keeps building towards this one single state machine and everything, it doesn't mean they could still lose a lot of liquidity to like some Solana rollup, kind of like unintentionally, right? And run into the same problems, even if they're not specifically designing for it or whatever, right? So yeah, I guess that would. But no, I agree. Like the architecture is definitely a lot different in Solana. I mean, Solana, Ethereum, and Celestia, which I would say are like, the three main like L1s that have a place in like the rollup eco now. They're all very different and kind of like the architectures, Celestia purely DA, no execution on it. Solana's got this like very highly scalable like finance chain. And actually I saw recently that like Sui is doing data availability sampling too. So that's like if you look at Solana and they got these rollups, Solana doesn't have like data availability sampling, right? And so I guess you could see like, yeah, I think the idea of like having this like shared state, highly scalable rollups on top kind of makes sense. But yeah, I mean, we'll see, right? We'll see. Ethereum's obviously the leader in rollups. Same with, I would say, Celestia too. We'll see how Eclipse does. We'll see how some of these other ones like Sonic, Magic Block and all that do. But yeah, definitely a lot of development going in this area. I think it is a good like a reinforcement of, there are more developers that are interested in like SVM and Solana ecosystem, right? And so, even if I think the bull case people always say with like Ethereum, it's like, okay, even if these rollups take away a lot of the value accrual from ETH, well, they have these very positive network effects on the EVM and developers, right? And I do agree with that point. And so, yeah, I guess we're starting to see it here in SVM. SVM is by far like the number 2 VM. I know there's like a bunch of other ones. There's like Wasm. There's like the MoveVM, Fuel, I guess. But SVM is definitely number 2 now. And yeah, we'll see kind of how this goes. But yeah, thanks for hopping on doing this pod. I thought it was good. If anybody is Delphi member, feel definitely like go read Solana the Modular. Prasad goes into all this stuff in great detail there. But yeah, thanks for hopping on and kind of giving the lowdown on what's going on in Solana rollup land.
Yeah, thanks. It was a pleasure talking to you.
All right, take care, everyone.